With the successful landing of the Perseverance rover on Mars, I thought now might be a good time to do a video on how some sound properties work on the Martian surface. So, how does acoustics work on Mars? Sound is going to be quite a bit different than here on Earth. The atmosphere is primarily carbon dioxide, which is very different from the mix on Earth, so the acoustics on Mars must have some big changes. The temperature is a lot different, and also the atmospheric pressure is a lot different. I'm not going to cover propagation in this video, but let me know if you want to see that in a future video. When the Perseverance rover was headed towards the surface, they stated things like subsonic. Was this subsonic on Mars or subsonic on Earth? This is a non-qualified answer because the speed of sound changes in different mediums in different places. Before we talk about Mars, let's cover the basics here on Earth first. On Earth, in air, at 20 degrees Celsius, the speed of sound is about 343 meters per second. For reference, commercial airliners often travel at 260 meters per second. 343 meters per second is the speed of sound, assuming a few things. So as it gets colder, this speed decreases. The temperature at 10,000 meter elevation is about minus 50 degrees Celsius, so the speed of sound is slower at 300 meters per second at this altitude. So unlike the speed of light, the speed of sound value isn't constant, so stating a speed of sound interval by itself has no meaning. Going Mach 3 in near absolute zero temperature means you're essentially not moving. The second component we need to talk about, aside from the speed of sound, is the ability to carry sound pressure levels or the volume that you hear. Think about the last time you were swimming underwater and you could hear sound from farther away than when you were above the surface. On Earth, we have an atmospheric pressure of about 101 kilopascals, or 15 psi absolute, near sea level. This is the dynamic range of the Earth to carry sound pressure levels. As you go higher in altitude, the pressure decreases, which decreases dynamic range of sound until you get to space where there's essentially no pressure and therefore no sound. Okay, so back to Mars. On Mars, the temperature is cold. The average temperature is minus 62 degrees C. And just for reference, the average winter temperature at the top of Mount Everest is minus 36 C. On the surface of Mars, the speed of sound is about 225 meters per second. Assuming pure CO2, it's about 95%, so it's close enough. So it will take longer to hear sound on Mars. On Earth, about 3 seconds for sound to travel 1 kilometer. On Mars, it will take 5 seconds for the sound to travel that same distance. Next is sound pressure level. How loud can sound be? Well, sound pressure level is often expressed as a decibel. More on this in a future video. The decibel is a ratio with a reference. Ratio with a reference. Ratio with a reference. What I'm saying is, remember that. The reference we use here is 0 dB is equal to 20 micropascals. So 94 dB equals 1 pascal. On Earth, that means the atmosphere at sea level clips at 200 decibels peak to peak. This is 2 times atmospheric pressure to an absolute vacuum per wave oscillation. No sound can be louder than that without creating distortion in the air or increasing the static pressure of air, also known as a barometer. If you decrease the barometer, you decrease the maximum possible sound pressure level. If you're using a cell phone dB meter, this is a root mean square or RMS number. The highest a typical sound level meter can go without clipping is 191 dB, reference to 20 micropascals. Your microphone will very likely break before this point though. Positive pressure waves, no oscillation, shock waves, can go many times higher than this value though. Think of an explosion. So how loud is sound on Mars? The atmospheric pressure is much thinner on Mars than it is here on Earth. This means the atmosphere is capable of carrying up to 156 dB peak to peak of sound pressure level variation before clipping, or RMS of 147 dB, reference to 20 micropascals. Not bad. So sound on Mars can make you deaf on your trip. So don't forget your hearing protection. To summarize, sound on Mars will be slower, 60% of the speed of sound on Earth. And the atmosphere can carry pressure waves loud enough to cause pain, 147 dB RMS. Exactly how far can sound go with the low atmospheric density is going to be a topic for another day. If you found this video useful, the best way you can support creators like me is to like our videos, subscribe to our channel, and of course, share our content. This helps the algorithm promote our work and allows more people to see our videos. Thanks for watching, and decibels will be out soon.